And what's even stranger, if scientists try to box in a particle, it will always generate enough energy to break out of the box before its position and speed have been determined. The uncertainty principle says nature will not allow its fundamental elements to be boxed in.
So because in the microscopic world, because particles will interact with a completely different set of rules, the rules of quantum physics, microscopic pool will be a completely different game.
The uncertainty of the microscopic universe extends far beyond the location of particles. It applies to everything, including a particle's energy, and this gives rise to a stunning phenomenon called quantum tunneling.
In classical physics, if you throw a ball at a wall and you don't throw it hard enough, it won't go through the wall, it'll bounce back. But if it's an electron and you don't throw it hard enough to go through the wall, it might go through anyway. We call that quantum tunneling.
How can this be possible? It may sound bizarre, but one way to explain quantum tunneling is that the uncertainty of the microscopic universe allows a particle to borrow energy from the future to breach the barrier and then pay it back after it gets to the other side.
The electron actually already is on the other side of the wall, and therefore it can go through it and appear on the other side of the wall.
Ever since these wonders of the microscopic world were discovered a century ago, people have asked if quantum tunneling, being in multiple places at the same time, and what appears to be traveling backwards in time, can be achieved in our everyday world. Some scientists say we'll never be able to throw a baseball through a solid barrier.
A baseball is a huge number of particles. You would need all of them to collectively suddenly appear in another place for the baseball as a whole to appear in another place. And that's just extraordinarily unlikely. A single electron or a single proton can do this. But the bigger your particle, or the bigger the collection of particles, the more difficult that process of tunneling is.